Hello, community! Why is AI language? Let's have a look at this. Currently I'm looking here at all the mathematical AI system. And you can have here this publication from the end of May 2024 about the mathematical understanding in large language model, or we go here, the LLMs in a hierarchical mathematical benchmark, or we go here, metacognitive capabilities of LLM and exploration and mathematical problem solving. And you say, yeah, okay, let's go also here. LLMs find mathematical reasoning mistakes by chain of thought. And it's all about mathematics in LLM, and they all kind of fail to deliver performance. And if you think this, you come up with an idea. And if you look at all this title, and this is just what I currently read, and you say, what is the common element in all of this? And it took me some time to figure out, it could be the language model. And I ask myself a simple question. Why do we want to solve mathematics in a human language model? At least we have an LLM that has the option of function calling. So we can call out to a Python system, define a mathematical model over there, execute the Python code or PyTorch or whatever you have, and come back to the model. This is what we call a tool use that the LLM is able to do. But no, everybody wants that the LLM itself is able to do and solve mathematical problems. In my last video, we were talking about RAG and the function calling abilities, and I showed you here this beautiful, simple equation. Do you see that it's an equation and not a sentence? What is an AI agent? It is an LLM, a large language model, plus a little bit of a memory, plus the ability of a tool use, a function calling to something, and a plan what to do. So, an agent that is indeed also an AI system, the concept of an agent highlights here the interactive, autonomous, and goal-oriented aspects of an AI. So an agent is an AI system, is an entity that perceives its environment through its sensors and acts upon environment through its actuators. So we're talking more or less about a robotic system that is really able to move in a three-dimensional ecosystem. And you might say, hey, wait a minute, should this not be here at least a vision language model or a vision language action model? Well, this is an interesting question, isn't it? And we have reactive agents, simple reflex agent like a thermostat, and we have planning agent. They use internal model of the world to plan action and make informed decision, our decision making of our LLM and hybrid system. And in my last video, I was talking to you about if we have those two elements, or maybe three if we include tool use. Now, a lot of people use LLM for the causal reasoning. And the advanced one use here the causal reasoning for planning here a strategy of our agent, of our robotic system that is moving around and has a task to fulfill. And more you hear about here this world model that is science-based, that describes here as a digital twin the environment, the real environment, and they should work together. Now, you say, no problem. So about memory, yeah, no. Either I go with in-context learning, or I have here this mighty new transformer family, this feedback attention memory internally in the transformer integrated, so no problem for the memory. For the tool use, you say, hey, Berkeley, you see Berkeley has a leaderboard where they just benchmark here the best function calling LLMs and vision language model. And you see number one is GPT-4, then Claude 3 Opus, and then Gemini 1.5 Pro. So those are the best function calling system. This is from exactly 1 year old here, Gorilla. We have language model that connect to massive APIs, and this is a fine-tuned system that writes API calls. This has been trained to produce API calls autonomously. Or you go, if you still remember GPT-4, once upon a time we had a code interpreter, a Python environment, a Python sandbox, where we could execute all our code. And this was so beautiful. Or if you say, hey, what about the code large language model? And I showed you here all the video. If you have here Code Llama, then here, if you fine tune your wizard coder, if you go with Copilot or Code Pilot and everything, and we move through all of those steps. And remember, it was always more or less that we had here in the Python file here, for example, these comments. When a human language, somebody described what the program is able to do. So you had this beautiful language, and then you had this code. And you already see what might be a problem with GitHub and everywhere you go. That sometimes the language description is not really up to the precision that the code implementation has been done. If I write code and I put in here my comments, honestly, I focus more on the code and the perfection of the code than to give here a perfect commentary description of what this system is able to do, what are its boundary conditions, when does this code operate, what have been my assumptions, what are the physical boundary limitation, do I use any shortcuts, do I use any specific time series, do I use any iterative calculations that I stop sometimes. All of this is currently missing, and you see where we get all the problems. And then you say, hey, no problem, we have multi-LLM systems. You know, we have here the primary LLM system, and then we have here the code LLM. And you're absolutely right. And we looked here at the multi-agent function calling in both of them. We looked at multi-agent, how to build them, how they interact. We talked about here the reasoning structure, if one is a chain of thought and the other is a graph of thought. You see, we had all these problems already here on our agenda. Now, if we look here at this planning dimension, just to give me one video here that I did here on in-context learning over graphs for large language model. Remember, Stanford University Prodigy, this video. So I think we as a research community, now for more than 1 year, we build, we develop, we have all the elements. And still, at the end of May 2024, we still have not solved that math works in an AI system. If you want to learn more about graph system, I have a whole playlist of 8 videos about link prediction with PyTorch or PyT, about SBIRD and whatever, about knowledge graph. I have 29 videos on knowledge graph. And if you ask me today, so what is now the solution that we have operational in our AI system? I can tell you, hey, yeah, we went beyond graph neural networks. We went to topological message parsing. We worked with simplicial complexes. But you know what? We have not achieved what we set out to do. So let's start in this video with one simple thought. And this is all that is here this video aiming for. One thought. Let's start. And again, we come back, what is an AI agent? And what we did is, hey, we apply a pattern recognition machine, let's say here transformer architecture, on what? Now we decided we applied here on human language, let's say English. And we built here a large language model where our LLM learned to mimic, to understand, to be trained on millions and billions of sentences, and now the LLM is able to regenerate sentences. Beautiful. Then we integrated vision, and we built a vision language model, and it worked. And then we said, hey, we need a vision language action models, Because we as human beings, we don't have any language. But we have visual detectors, our eyes. And we interact, we have action with our community. So this is where we are today. LLMs, VLMs, and VLA systems. But you know what? Think about it. On May 25th, 1961, talking about this plan, what to do, a nation decided to set itself a new goal to put a man on the moon. And you know what? The human language stopped working at this very moment because nobody knew how to formulate a sentence about at what coordinates the spacecraft in the gravitational fields on Earth and Moon will start to descend to the surface of the Moon if at a given velocity, if at a given vector. How you want to describe this in a human language? We have no experience, we have never done it before, and the human language simply stopped working for this purpose. So what we did we invest more in a large language model, in the human language, and made the language better? Or did we use here a more formal scientific language? We used physics, we used fluid dynamics, we used mathematics to calculate the trajectories, how long you have to burn your engine, what about oxygen. This was not done in a human language, but this was done with mathematical formulas. So just to show you this analogon, in 1961 our human language broke. It was gone. We were not able to use it anymore, so we switched over to a scientific, mathematical formulation, and we could build our rockets that had exactly the power that we needed to reach the moon. And the first reports here at NASA were typed here really on paper. And you know what? The first calculations were done by hand. And then later, I think it was an IBM mainframe, they started to use computer for those calculations, for those mathematical calculations. And those tools like a rocket and a communication and a calculation enabled us to send a man to the moon. So is there something that we can learn for today? What do we want to achieve today? When does now the human language break? And does it make sense to focus more and more on large language models? I did a video here on AI world models that explain the world. And then we went here, you remember Sora? It was celebrated as a world model. No, we just went from vision language action model to a pure video sequence model. That's all there was. And I did a video because whenever Sora was released by OpenAI, it was already 1 year old. And I showed you in this video how we can do a technology update to modern technology for Sora, for not be so old. But what if you're going to go today and we have set ourselves new goals? Let's say we want to go to other planets or to Io or Ganymede. Will a human language be enough to project our trajectories to go there, to do all the calculations? And you see, we switch over to calculations, to mathematics, to physics. I would like to fly over Enceladus about these cryovolcanic eruptions. I would like to see this. So what is now this main sword of today? Looking back, we see, we applied here a pattern recognition machine, let's call it a transformer, on the human language. And it was amazing the success we had in the last years. But now we run against the wall. We run against the wall and we continue to run against the wall because our wish is an LLM should be able to understand mathematics. And maybe it is time here to say, hey, what do you think? We start now with all the knowledge that we have from this section, and we apply it now on a new idea that we build here a pattern recognition machine on science, on a formal logic, on a mathematical logic, on physical laws, on chemical laws. We build a large mathematical model. Maybe we build a large astrophysical model. And we do not go the path that we say we build now a vision, language, action, video, mathematical model. Because maybe the complexity in this model that you need, I don't know, 10,000 GPU just to start running this model. Maybe this is not the way we as a research community want to go. That only, I don't know, NVIDIA, Amazon, and Google or Microsoft is able to do this. So you see, this was just one thought. Now, if you know me, you know I have some personal reflection at the very end of my video. It was interesting to see that exactly one day after I published here my latest video on YouTube, AWS, Amazon published this. AWS, HPC blog, building an AI simulation assistant with agentic workflow. I say nothing about agentic, this is already part in my last video. But you know what they did? They were focusing here on an AI-based simulation assistant. So kind of simulating here a financial system, maybe a physical system, maybe a chemical system. And they said, hey, and we do this here with LangChain agents. And they chosen here, for example, in Amazon Bedrock here, specific LLMs. And I said, why do they stress here the LangChain agents? And going there to LangChain, I understood immediately. Look at this. They say here, LangChain, in agents, a language model is used as a reasoning engine to determine the actions to take and in which order. So if we look here at the original idea of an agent, an AI agent, where you have an LLM and this, and then here this planning, maybe this is also an intelligence. LangChain agents are defined that a language model is used here as a reasoning engine. And this changes the game. Because what they say here, we don't go with the classical AI agent, we go with the LangChain agent, where our language model is now our reasoning engine. And you see again the same behavior pattern. Like at the beginning of my video, I showed you, LLMs have to understand the pure logic of mathematics. And now here we have the language model has to be the reasoning engine for the complete system. And it's amazing. And then naturally, if you have this as your reasoning engine, you do not need another, maybe secondary intelligence to do the planning, the strategy for you. So you put all the intelligence here in this basket. And I had to smile because this basket by AWS is not as easy as you might think. This here is, for this simulation analysis, exactly what you as a user of AWS Cloud have to pay for. And you pay for each little box, you pay for each little element. What a coincidence. And you see the complexity they built just to have an LLM with a simulation tool. Look at how complicated you can build this in order to activate all your pay for function by Amazon. I think it's a beautiful image. And then if you go there, they also say, yeah, enabling now our agentic behavior, we have something that is called tool use. And they say, yeah, this is a function calling. And I said, We had this argument in my last video, but it was good that I have here kind of a check what is currently going on in Amazon and AWS. But the most interesting part was when they said about what is our future work at AWS? What are we striving to do in the next AI evolutional step? And they said, this simulation assistant demo achieves a lot, but, and what they are looking for, what AWS is looking for is to integrate here, of course in open source, computational fluid dynamics software as a tool. So this is exactly what I argued in my video. Why do we not use here the function calling capability, activate a tool like a Python program where we have simply a software program about computational fluid dynamics that we have in theoretical physics or material science or geophysics or whatever you like. It is there. We have those programs. Why don't we just build here the channel out to the programs, let the programs run, and the result comes back? Why we have to integrate everything into a language model? My goodness. So if you look at this now here, there's something interesting happening. Look at this. If you look at a classical AI agent definition, you see this here, this computational fluid dynamic software, this is a plan what to do, or a large logic model. So not a large language model, but a large logic model. And I've chosen this particular, that is also LLM, but different. It is now about logic and not about human language when we talk about gossip, or we talk about news, or we talk about, I don't know. Look at this. If this is what the classical AI agent model wants to achieve with a secondary source of computational intelligence, let's call it here, yeah, why not go with this fluid dynamic software that calculates for specific parameters, for a specific boundary condition, at a specific temperature, for a specific fluid dynamic situation. We calculate here how it will behave in the future. So we have here a large physical model, a large mathematical model, call it whatever you like. AWS agents now are something a little bit different. They do not say, hey, yeah, we built here another intelligence that is able to do this and understand it. We use this only as a tool. Interesting. So AWS in this publication says, we only want to have one central intelligence in our system, and this is the language model. The language model decides everything. We have here this complexity so that it works with a language model. But as I've shown you on our way to the moon or the way to Mars, you can't language your way to Mars. You need to calculate the flight path. You need to calculate how much oxygen you have to take with you. So this is interesting if you still put all the intelligence for the decisions now in a large language model and you train this. And I understand for a cloud provider like AWS, this will be a monster system. You will need thousands of GPUs. I understand the business idea behind this for AWS. But we have a second opportunity. We can build we have it a large language model with a tool use. But then we start to build something specific, a mathematical AI system for computational fluid dynamics that we already have. And then we just do not treat this as a software that we activate and deactivate after it provided us the result. But can we find the intelligence in this? With an LLM, if you want to stress it to the limit, we can say the LLM found the intelligence, the semantic patterns in our human language. It would be so amazing to see if a mathematical AI system would find the intelligence in a fluid dynamic system, if it would not just calculate what we as coder hard code in the program, but if the AI logical system would understand why fluid dynamics behave in the way they behave. So you see two completely different ways in our future. But maybe you feel that I have a preference not to further blow up the LLMs so that only 2-3 companies in the world have the software and the infrastructure to do this. I would like to keep it open source and accessible for everybody. But you see, if we build now 2 AI systems, this increases the complexity for AWS significantly. Because if they only build this for an LLM, and now they have to build a second AI system, a science model for the fluid dynamics, the complexity of the system is really showing, you know. So there is a breaking point that you understand as a company that this is not the way forward for your customers, for your clients. So this is now a fascinating moment in time, and this is happening right now. Right now, the decision, are we going in our future with extreme LLM configurations, or are we trying to be more on the specialized side, on the expert side, and build secondary or additional AI system for a mathematical AI system or a pure logic system or a fluid dynamic system where we discover the kind of intelligence behind our physical systems, that we do not just understand that we can execute a formula, but we understand the mechanisms on a molecular level, on a level of atoms, why certain physical systems behave in the way they do. And this is something I, as a theoretical scientist, I would be so interested to see. Can we find kind of a new physics if we apply AI and dedicated AI system to our old, let's say, fluid dynamic software systems? Will we find new ways, new modes of operation that a fluid dynamic can behave? Maybe at extreme temperatures, maybe at extreme pressure, but maybe we don't have to do all the experiment for this. But maybe we find here the understanding why the configuration of molecules behave in this particular way. You know, those laws of nature now on the next level. If this is it that you're interested in, I think AI has an interesting future. It's gonna be amazing, but it will depend what model and what way forward will be chosen, maybe not by the scientific AI community, but maybe just by 1 or 2 global players on this planet. So I hope it was a little bit interesting for you also to have a different view of what is coming up in AI. It is not just about one model, or we increase now the performance another 2 percentage points. There are some fundamental decisions that have to be taken right now. And nobody's talking about it. And I find this interesting. So if you enjoyed this, hey, it would be great to see you in my next video.